Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, like we do every Tuesday, we're going to do all things math for your teacher certification exams. So welcome to another Tuesday session. We've got 10 problems for you to do. We're going to just jump right into it. I know it's the middle of June. Those of you that are getting certification letters and trying to line up your jobs for next year, you got about 2 weeks left before that June 30th cutoff date. So make sure that you're signed up for your certification exams and you've got everything ready to go. So if you have any questions or comments, please go ahead and get me in either Facebook or on YouTube. We are live on both platforms, just like we go live every single Tuesday. And I will go ahead and make sure that I can see what it is that is going on. Sorry, I'm just trying to see everything just in case anybody's got any issues. Let's go to here. Okay. So yeah, so go ahead and throw any comments into the chat. I will take care of them as they come up. And I will usually, it probably takes me to about problem 5 when I realize somebody's put a comment in. So just bear with me on that and I'll kind of scroll back if I need to. But for the most part, if you have any questions, go ahead and hit me up live. If you're watching this on the recording, then go ahead and send me an email. That'll be at the end of the session, but it is info@KathleenJasper.com. And then I get all of those math questions, all of the problems that you want me to do during the weekly sessions and so on. So let's go ahead and just jump right into it. We have 10 problems. Don't forget, make sure you have your calculator with you. All right. Because most of you do get a calculator on your exam. So make sure you have the correct calculator with you. In this case, this is my TI-30. This is a scientific calculator. A lot of the tests give you this, but otherwise make sure you check a regular 4-function calculator, which you can get at the dollar store, or there's one that will be embedded into the actual test. Look up the test that you have, and it will tell you which calculator they will be using, and also give you a tutorial if it's an online calculator as well. Then make sure you have your scratch paper. It's important to be practicing with scratch paper, whether you're watching this video or you're using a study guide or printouts to do your problems, because you won't be able to write on the problems or on the test when you're taking the test. So make sure you're practicing with that scratch paper so that you get it down to where you have to look up at the problem and then transfer any information down to scratch paper that you're going to use to do the problem. Okay, let's go ahead and jump right into it. These 10 problems are, they're not for one particular test. That's the biggest question I get when we do these sessions. This is not for one particular test. This is just for math in general. These types of problems show up often on standardized math assessments just because of what they are assessing. It's tied to a lot of the math standards that you see in your math blueprints. So this just touches on a lot of, if you understand the math that I do during these sessions, then you should be good to go. Okay. And then I try and show you as many tips, tricks, whatever, shortcuts as we go along. This first problem says triangle TUV is shown on the coordinate plane. Triangle TUV will be reflected over the x-axis. The image of triangle TUV will then be translated 2 units up and 1 unit left. What will be the coordinates of the final image of point V after the 2 transformations? So that's what this is called. Whenever you're moving something into in the coordinate plane, specifically these shapes, it is called a transformation. So it's a geometry term. They assess this because they want you to know or they want to see if you know how to do this. Honestly, all this is just a set of instructions, right? I've given you a set of instructions or directions. That's even better. I've given you a set of directions. Start from one point and then follow my directions. Where do you end up? That's all a transformation is. Transformation also means that we're moving this object. The common transformations that you see are reflections and translations, and that's what we have here. So we start with the first one. It says triangle TUV will be reflected. Well, what does reflected mean? Reflected, think of in a mirror. When you look straight into a mirror, you are seeing your opposite self. All right. In this case, it says the x-axis. We are reflecting over the x-axis, which means your x-axis would be your mirror. So I want to see the opposite of this shape here, and this is TUV. That's what they say, triangle TUV. That's TUV right there. That's why they have the letters TUV. Specifically, point V is what we are looking for. So that's all I want to focus on is this point right here. Don't worry about anything else. We want to take that point and we want to reflect it over the x-axis. So here's how we reflect something. I've already shown you we're going over the x-axis. So from the x-axis, which is here, it should be equidistant, okay? Equidistant from your reflection point. Point V is up here, which means I go 1, 2 to get to the x-axis. So it's a distance of 2. Well, that means I go 1, 2, and now my reflected point V is going to be here. If you see this in problems, you will see it as, it'll be called V, and then it'll have a little apostrophe. It looks like a 1, but we call that V prime. We'll do that right there. So you don't have to worry about that, but that's what that says. It's really what happens to that point after it's made its first transformation. So we reflect it over the x-axis. You can do it with the whole shape, and I don't know why you'd want to, because you're only focused on V. That's another thing. Don't jump in and say, oh, I got to reflect this whole thing. If they're only asking for V, just use point V and that's it. So I go to, I've done my reflection. Now I need to translate. And when it says translate, it just means it's being moved. And it's going to tell you, in this case, it tells you 2 units up, 1 unit left. Well, that's pretty easy. So I start here and I go 2 units up. So I go 1, 2. I'm right here now. Let me move that line for you. I'm sorry if this is a little small, but I try to fit everything on one screen here. Let me see if I can. Let's do that. Okay, that's better. So you see how I went up to here, and then it says 1 unit to the left, and then 1 unit to the left. So this point right here is my new point, because I reflected over the x-axis, then I went up 2 and left 1. I know that's really confusing as far as that squiggles, but ultimately that's what you get. Okay. So now what is that point? Well, we should know how to write points. Points are written as X comma Y. Always do your X first. So starting at 0, 0, I need to go to the right 4. So it's going to be 4 comma, and then I don't move up or down. So it's 0. So I know that my point that I'm looking for is going to be 4 comma 0. And that is going to be answer B. Okay. I just wanted to do that problem because you may see transformations on any number of exams, okay? Because this one, they can do it on a lot. They can be more complicated than this. They can be simpler than this. But when they're asking you for these reflections, these transformations, these translations, this is all it is. All right. Okay. Next problem. It says last year, about 2,400 people participated in a local 4th of July parade. This year, about 3,200 people participated. What was the approximate percent increase in participation? All right. Percent increase. So I'm just going to tell you how to do these problems. There's a formula for this. All right. And some people get confused by the formula. So I'm just going to show you what you need to do. All you need to do is this. You take the difference. The first writing is always the worst. Not like this is any better. The difference over original. So now this is going to make sense here. If we had 2,400 and we now have 3,200, we take the difference of those two numbers. In this case, if I did 2,400 minus 3,200 and then divide it by the original, which is 2,400, here's what I get. I get 6, it's 800. 800 over 2,400, which is equal to 0.3333, right? You get it. Now, 2,400 minus 3,200 is negative 800. Does it make a difference? It does not. I'm just telling you it does not. They already told you it was a percent increase. So in this, you take the new value and subtract it from the old value. That's what it is. But sometimes people get so hung up on which one do I put first? Which one do I put first? If you just follow this, the difference over the original, the negatives don't matter, honestly, because they already told you it's an increase. So that should tell you already, well, that means the bigger number has to be, the bigger number has to be subtracted from the little number, or vice versa. Sorry. So you see that I get the 0.333. I'm going to show you if you did it the other way. So let's do 3,200 minus 2,400 all over 2,400. Well, now we get positive 800 over 2,400, which is still 0.33, okay, which is still 33%. D is the correct answer. It doesn't matter if this is positive or negative. We already know it's a percent increase. This technically is the right way to write it, but who cares? Just know that whenever you're looking for a percent increase or decrease, it does not matter, okay? Percent increase or decrease. You always take the the difference of the two values you're given. It doesn't matter which way, because you're going to get the same number. It doesn't matter about positive or negative for the purposes of this exam. Trust me, because all you're looking for is to get the right answer, because 3,200 minus 2,400 is still the same number as 2,400 minus 3,200. It's still 800. One's positive, one's negative. But again, I don't care, because it's always going to be that number divided by the original value, and you're going to get the right number. Just think of it as throwing away the signs. Don't worry about it. Okay. So I wanted to show that, because you will see percent increase and decrease somewhere on your exams. Okay. Next problem. We've got, yeah. Oh, you know what? I probably should have done that. So I got a question here on YouTube. So let's kind of go through. I kind of skipped over that. It's good that you got me on that. 800 divided by 2,400 it gives us this 0.33. Well, if we're looking for turning into a decimal point into a percentage, likely you can see 33 here and 33 here. They're not going to have two of the same numbers unless they have 3.3%, but be careful with that. So I've got the 0.33. Okay. And so then 0.33, in order to make a percent, we just do like this, bring 2 to the right, and then you get 33%. Or because we are at a decimal, with decimals, you always multiply by 100 and you'll get 33, and then just add a percent to it. Question says, how would I solve without a calculator? Texas doesn't allow any calculators at all. That's interesting. I find that hard to believe. I don't know that off the top of my head, but in the event that we don't, we can go ahead and if they make you solve a problem like this without calculators, you can do the 3,200 minus 2,400, and then you get 800 over 2,400. Let me draw this a little better. 800 over 2,400. Anything with zeros, 1 0 will cancel each other out. We're now left with 8 over 24. If we go ahead and see, can we take 8 or anything, a factor of 8 out of 24, and you can take 8 out of 24. So you would be left with 1 over 3, and 1 over 3 would be a fraction. If you don't have a calculator, then you need to memorize some fractions. If you don't know what 1/3 is as 0.33, then I suggest you memorize those, like 1/4 is 0.25 and so on. But in the event that you have another fraction, let me show you a quick way to solve fractions. So let's clear this off. You've got a fraction, you got to put it in a decimal, and you don't have a calculator. Real quick, let's take 1/3. So you do an equal sign, okay? And then you add a 0 to the top. Put a decimal point here. Anytime you add a 0 here. So we do, how many times does 3 go into 10? 3 goes into 10 3 times. So 3 times 3 is 9. 10 minus 9 is 1. Add another 0. How many times does 3 go into 10? It goes in 3 times. Minus 9 equals 1. Take it away as 0. All this is just a short form of long division. It's kind of the opposite way of doing it, how we go up. And that's why 1/3 is 0.33, because it goes 3, remainder 1, and then solve it again, 3, remainder 1, and then solve it again, and so on and so forth. So that's why it goes on forever. Okay, oops, that's 1, 0. And that's how you do that. What if it wasn't like that? Let's pretend you've got 2 over 7. So again, we do equal sign, decimal point. Now we go ahead and add a 0 to the top. How many times does 7 go into 20? It goes in 2 times, because 2 times 7 is 14. So take 14 away and you end up with 6. So that's gone. Add a 0. You're always adding zeros. Don't forget, you've got to add a 0. How many times does 7 go into 60? So off the top of your head, you're like, how many times does 7 go into 60? I don't know. 7. Do it in your calculator. It's fine. Doesn't matter. Know your times tables. But 7 goes, we go 8 times, because that gives me 56. And so 60 minus 56 is 4. Cancel that out. Add a 0. How many times does 7 go into 40? And you do 5, because that's 35. And then you end up with 5. And then how many times does 7 go? Okay, you can keep going on and on and on. For the most part, you only need to go probably 2 decimal places, no matter which test you're taking. So if you don't have a calculator, That's a way to put a fraction into decimal form. Hope that helps. Problem 3, got a chart. Says Gavin can spend no more than $300 on the catering for an event. What is the greatest number of people that Gavin can have at his event without spending more than $300 on catering? So they're giving us three different options, and we've got $300. What is the most we can get out of our $300 is basically what this question is saying. So right away, just go through and figure out each one. There's really no shortcut here. You've got to do the work, but you got to understand each scenario. Acme Catering, $6 per person plus a flat $100 time and equipment charge. So we start with $300. So we'll start with the Acme one. Let's just put it here. I have $300. I take away my $100 one-time fee. That leaves me with $200. Now it's $6 a person. So divide by 6 and I get 33.3. Now, how many people can you serve if you come out to 33.3 as your number? You cannot have a fraction of a person. So always round down to the nearest whole number. So this equals 33 people. Okay. So if he can do 33 people, well, we're looking for the what is the greatest number I can do? Well, we know 32 and 30 are out. So right away with our answer choices, are we going to get up to 37? So in our calculator, we can go ahead. I've got 300. You can do it in your calculator. You can do it on paper. I'm just doing it on paper so you can see it. 300 minus 40 gives me the 260. Then I want to divide by 8. So 260 divided by 8 equals 32.5, but it doesn't matter because I've already got 33 here. And then finally, $10 with no fees. So 300 divided by 10 equals 30. 33 is my correct answer. Okay. So that's it. Just kind of run through it. Don't try and, there's no crazy equations. Just logically go through the motions of figuring out each company, and you should be able to do it within the time allotted for this problem. Either do it just solely in your calculator or write it down. Reason why I say learn how to use your scratch paper, because the more time you can save by just punching things in your calculator and then writing a couple of things down. Like in this case, I could do it in my calculator, and on my scratch pad, I can just do, and I would put something, but like 33, 32, and 30. So obviously this one's going to be the highest number. All right. The formula for the area of a trapezoid is area is equal to 1/2 base 1 plus base 2 times height. Solve for base 1, which equation is a correct value for base 1. These are called literal equations. I know there's a half number in there, but for literal equations, it just means you're moving letters around. And this gets confusing for people because their brain says to themselves, I'm not supposed to math numbers, right? I'm supposed to math numbers. I'm not supposed to math letters. So this could get confusing, but it's real simple because all you have to do is just everything you already know about math. All the concepts are still there. It's just letters, not numbers. First thing we need to do is go ahead and write down what it is that we're looking for. So I have area is equal to 1/2 base 1 plus base 2 all times the height. We need to isolate base 1. That's this right here. How are we going to get that away from everything on that side of the equation? So it just is going to take baby steps. the first thing you can do is you can get rid of this 1/2. So how do you get rid of 1/2? Well, in order to get rid of it, because it's 1/2, multiplying by the value, you would divide by 1/2. Dividing by 1/2 is the same as multiplying by 2. Or with any fraction, you can always multiply by its reciprocal and you get 1. All right. The goal is to get rid of that fraction. Get that 2 on the other side, on top instead of on bottom, and that's what you get. So we want to multiply everything by 2. Remember, whatever you do to one side of the equation, you have to do to the other. So I'm going to go ahead and multiply by 2, which means I multiply here by 2. I'm now ending up with 2a is equal to, that cancels out, and then the value b1 plus b2 times my height. I've got these in parentheses, so I can't touch them yet because of this guy right here. So if this is multiplying by the value, the opposite would be divide. So divide both sides by h. I'm now left with 2a over h is equal to the value b1 plus b2, and that cancels out. Now, this is just b1 plus b2. Even though it's in parentheses, there's nothing going on either side here. So if nothing is going on either side, I can get rid of these parentheses. The last thing I need to do is to just get b1 by itself. And to do that, I can just subtract b2 because b2 is being added to b1. Do the opposite, which is subtract. So we go ahead and subtract b2. That's going to cancel out. Let me get rid of this. I'm sorry, I ran out of room, so that we can rewrite this correctly as 2a over h minus b2, base 2. Looking at our answer choices, this one doesn't look like it. 2a over h minus b2. That's pretty close because that's what it is. And then a over 2h. See, this one is just the opposite. So that's not going to work. And then 1/2 AB, that's not it either. So B is the correct answer. Just please remember, when you're doing literal equations, treat them as if they were numbers. You can still multiply something that's being divided to cancel it out, divide something that's being multiplied, add something that's being subtracted, or subtract something that's being added. Everything that you know how to do with numbers can still be done when you're given these variables in literal equations. Okay, question 5. And I always like these because it gives you a problem, but then the answer choices aren't necessarily just do the math. It's kind of like a scenario based. Which student correctly solved this equation? We have x to the 1/3 power times x to the 1/4 power. And we have all of our answer choices. In this case, Joe says the answer is x to the 7/12 because the exponent should be added. Carrie says the answer is 2/7 because the exponent should be added. Alex says 7/12 because the exponent should be multiplied. Tracy says 1/12 because the exponent should be multiplied. How do we do x to the 1/3 times x to the 1/4? So something you need to know is when we have fraction as exponents, you have to have the same base in order to do this. So x is the same base, which means I can do something to these exponents. Well, when you're multiplying, that's this right here. When you're multiplying with fractional exponents, what are you supposed to do to the exponents? If the bases are the same, that means you add the exponents. So we should be adding 1/3 and 1/4, which means anything that says multiplied is wrong. So right away, C and D are incorrect. And what we can do by that is we've eliminated half of the answer choices. We now have a 50-50 shot. So at least if you knew that, you could get that down and take an educated guess. Now it's just a matter of adding fractions. Okay. So do you think it's going to be 2/7, 7 being the denominator when you have 4 and 3? And they do that on purpose because you think, oh, if I add it, I just do 1 plus 1 on the top and 3 plus 4 on the bottom and get 2/7. That is not how you add. So if you knew that, you can just look at that answer choice and say, well, I know already that that's not going to be right, and go ahead and cross it out. And we know A is the correct answer. Otherwise, go ahead and do this. I know that 12 is going to be my least common multiple. So least common multiple is what you want as a denominator. 3 needs 4, so 4 is going to go on the top. 4 needs 3, so 3 is going to go on the top. We have 4/12 plus 3/12, which gives us 7/12 being the answer. Okay, so even if you just added these first, you'll see 7/12 and 7/12. Well, you just have to realize we added them, not multiplied them. So A is the correct answer for that. Okay. All right, let me just check, see if there's any comments. Okay, YouTube is good. Let me try. Oh, okay. Sorry, I think you're okay. Is this from Praxis 5903? Again, so this isn't for any particular Praxis or teacher certification exam, but this kind of math will help you regardless of what test you're taking. So it's just good. Listen, if you're taking a math test, it's always good to be doing problems. And in this case, the problems that I provide for you, they are problems that are commonly found on standardized math tests. And so just seeing these problems over and over and being exposed to them, you know, no matter what test you're going to be taking, is going to help you. Okay. Problem 6. We've got which statement is correct based on the data. All right. So always love these types of problems because they like putting graphs and charts and all sorts of things on these tests because it takes up a lot of the screen. It can be overwhelming when you click to it. And I want to make sure that you know there's nothing too difficult to these problems. We have the number of cars sold on this graph, number of cars are here, and then the temperature. So that's interesting. It says, which statement is correct based on the data? So let's look at the answer choices. And that's all we're gonna have to do. We have to go through the answer choices and just knock them out one by one. The temperature gives no indication of car sales. Well, if we look, we have a trend line here. And this trend line shows that as the temperature increases, right, we're going this way and it's getting hotter, then the number of cars sold also increases. When it says the temperature gives no indication, well, according to this chart, because that's what we have to go off of, temperature does give an indication. So we cannot say that this is correct because it says no indication. So it's really to some extent true based off the data that we have here. And that's the thing. It's based on the data. You're only looking at this chart right here and nothing else. The next answer choice says, if the temperature is 50, the amount of car sales will definitely be 4 cars. Well, let's go to 50 degrees, which is here. And when we go to 50 degrees, we see that we have this right here. It says the amount of car sales will definitely be 4. Well, here is 4. Okay. Is it definitely going to be 4? That means, is it going to be 4 and 4 only? You've got to be careful how you read these. And that's why they put this language on here, because you're saying to yourself, well, it's a definitely 4 because I see it's 5 and 7. But when they say definitely 4, that means it's got to be 4. So be careful with language like this in these problems. It will get somewhat confusing. This one's out because we know that it's more than 4. Our next one, the higher temperature is correlated to higher car sales and causes car sales to increase. Well, that sounds good, right? Because the higher the temperature, I see high temperature is correlated to higher sales. That's right. Higher the temperature, higher car sales, and causes the car sales to increase. So does temperature cause car sales to increase? Based on the data, that looks right. So I'm going to hang on to that one. And let's go to D. The higher temperature is correlated to higher car sales, but does not necessarily cause the car sales to increase. Okay. So what is the difference? C says it's causing car sales to increase. This one says necessarily, does not necessarily cause the car sales to increase. So based on the data, this is where these two differ. C says the higher the temperature is correlated with higher car sales and causes car sales to increase. Well, that means every single one of these should be greater than the next. See how these two are the same? See how this one is below this one? Well, if it says higher car sales cause, that means no matter what, if you have high temperature, you're having high car sales. You would never have that one or that one or that one, right? I know it's a matter of semantics because with D, the higher temperature is correlated. Yes, correct, it's correlated, but does not necessarily cause, it doesn't necessarily cause the high car sales because we get these little outliers here. And again, we're only going off of this chart. So these three right here are what can give you the right answer correctly using D, because it says not necessarily. It's the more right answer, okay? And again, it's a matter of semantics and a couple of words. So just be careful with problems like this because they will be tricky, even though you're just looking at it at a chart that you would think and otherwise is nothing too deceiving. All right, next question. The following function was used to calculate the profit generated by selling t-shirts. Let f of x equal 15x minus 25, represent the profit function, and x represent the number of t-shirts sold. Which statement is true of f at 200? When you're given these function problems and then function notation, which is this right here, and then they give you that, some people get very confused as to what this is. So let's just look at this and then take this, for example. If I have f at x, and then I have f at f at 200, what do you see here? You see x here, and then you see 200 here. The f and the parentheses are all the same. If I take this x, now see how it says 15x minus 25. Well, now see how everything that was x is right here. Now what we do is just take 15 and put 200 in. All this is, whatever's in parentheses gets substituted for the x value or the variable's value. That's all this means. So then we go ahead and we run the function just like that. Okay. So knowing this, if you do 15 times 200 equals 3,000 minus 25, you get 2975. So what does that 2975 mean? As we look at the answer choices, it results in 15 and means that 15 t-shirts, well, it's not 15 because it's 2975. So we can eliminate A and B right away. C says it results in 2,975 and means that 2,975 t-shirts were sold. Is that what that means? Because it says X represents the number of t-shirts, which is this number here, which is this number here, which in turn is this number here. There were only 200 t-shirts sold, not 2,975. So C is out, making D the obvious answer. And the reason for that is it results in $29.75 and means that $2,975 was made in profit. That's what it is. This 25 right here is your cost. Anything after this $25 now is your profit. So that's why we take however many we sold, 200 at $15 each, take away 25 bucks. That is our profit. D is the correct answer there. All right, next one we have Tony is reseeding the front lawn. The lawn covers 2,500 square feet and grass seed is $15.98 for each 7-pound bag. Each pound of grass seed covers 150 square feet. How much will it cost to reseed the lawn? All right. How are we going to figure this one out? Well, again, with these types of problems, it looks like we're going to have to figure out area and draw some shapes and do all that kind of stuff. But just be careful because of what information they give us. The lawn covers 2,500 square feet. So that's our first piece of information, right? Here's our lawn and it's 2,500 square feet. So does it help us by drawing a picture? Maybe it helps you drawing a picture. Maybe it doesn't. I don't know. But I just know we've got 2,500 square foot lawn. What are we going to do with that 2,500 square feet? Well, we know that we have only 7-pound bags. 1 pound gives us 150 square feet. So we need to figure out how many pounds we're going to need for our yard. So let's go ahead and do, let me get rid of this. Let's go ahead and do 2,500 divided by 150. When we do that, we get, let's round it out, 16.7. So what does that 16.7 mean? That 16.7 means pounds of seed, right? Because every 150 square feet, give me 1 pound of seed. There are 16.7 150 square feet in 2,500. I know that sounds crazy. Like here's our 2,500. And then each one of these is 16.7. There would, oops, I'm sorry. Each one of these is 150 square feet, right? 150 square feet all the way till you get 16.7. Well, each one of those represents 1 pound of seed. That's how we get 16.7 pounds of seed. Next, we need to figure out how many bags we have. So each is a 7-pound bag. So take 16.7 and divide by 7. And you get roughly 2.4. So if I need 2.4 bags of seed to do this, how much is that going to cost? And so some people might just do 2.4 times, right? If it's only 2.4 and it's $15.98 for each 7-pound bag, well, I only need 2.4 bags, right? So I do 15.98 times 2.4. And you get 38.35. You see that they have 38.35 here. Here's the kicker. Boom, 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 right here. This is what they want you to get confused with. If you went into Home Depot or Lowe's or whatever your favorite hardware garden store is, then, and you went in there for grass seed and you said, hi, I measured out my yard. I know that I need, you have 7-pound bags of seed. I know that I need 2.4 bags. And they're going to look at you and they're going to say, okay, we can't do fractions of bags. obviously, right? You can't go in and buy a fraction of a bag. So when you're figuring out problems like this, where they're giving you a certain value, or if it's dealing with people, or if it's dealing with tile or bricks or trees or, any object, we cannot take a fraction of that object when we're in the test world. So your certified tests, you cannot take the fraction of that object, which means, and that's why they put 3835 as an answer choice here, that you round up to the nearest whole number. So rounding up to the nearest whole number is going to give me 3. I know that I need 2.4, but I can't buy 0.4 of a bag. So I have to go up to the next whole number. Always round up to the next whole number. What if it was 2.01? Well, guess what? It's still 3. It's not 2. It's greater than 2, which means I have to go to the next whole number up, because if it was 2.01 and you bought that, you would not have enough seed, technically speaking. Now, I know this is on the dramatic level because you're never going to get it at 0.01. You think to yourself, oh, how big of a deal is 0.01? That's not it. It's the principle of the fact that this problem wants to know, do you know how to round up? Because this is 7-pound bags and 7-pound bags only. So that would be 3. Now you would do 3 times 1598, and you would end up with 4794. D is your correct answer. Okay. All right. Next one. A computer program selects blue, red, or green as the background color each time the program is used. The program was used 45 times on the same computer in 1 week. Of those 45 times, a blue background appeared 12 times and a red background appeared 21 times. Based on this information, which statement about the likelihood of the green background appearing the next time the program is used is true? Okay, that's a lot going on there without a lot of numbers or functions or really anything to kind of tip me off as to how to solve this problem. So again, when we're confused like this, the best way is to just go through it logically. So we've got this computer program and it's 45 times. There are 3. There's blue, red, and green, but they only give us blue as 12 and red as 21. The answer choices are telling me green is just as likely as red or blue. Green is like, so it doesn't need a value. So I don't need to solve anything for a specific value, but I just need to understand when green is going to appear. Because there's these 3, they gave us 2 out of the 3, we can find the 4th, right? So if I did 41, or not 41, if I do, let's do this. I've got blue, red, green. Blue is my first one. I got blue at 12. So blue is equal to 12. And then I have red is equal to 21. And then I have green. Well, how do we figure out what green is? Well, if they gave us what red and blue were, then, and they gave us the total, then that means I can take this 45 and I can subtract 21 and then subtract 12, and I end up getting 12. So there are 12 green backgrounds that appeared during this 45 times that this program was used. So we go through the answer choices, and you should notice something here. Notice how these are the same numbers. That's interesting that they're the exact same numbers, because when we read the answer choices, it says green is just as likely as red or blue to appear. So is green just as likely as red or blue? It's just as likely as blue because there's the same amount of blue, but it's not as likely as red because this is a totally different number. So A is not the right answer. B says green is just as likely as blue to appear, but not as likely as red. Well, that makes sense. Green is as likely as blue because they're exactly the same. They have the same exact probability of showing up because there's 12 of each of them. but not as likely as red. And it's not as likely because it's actually less than red. So red is more, which makes this the right answer because that makes sense. It's not telling you that green's going to show up, but based off of the amount of each of these three, the probability is blue and green have the same. Red is more because there are more reds in this program. C says green is not as likely as red or blue. Well, that's not the case because it is likely as blue. And then green is not as likely as blue to appear, but is as likely as red. Well, no, it's not, because not is not right because they are exactly the same. So that's why that's wrong. So I like to throw these problems in here just because they're a little bit of thinker problems. You have to find that missing piece. That's the biggest part of this, is figuring out the missing piece, how many greens there are, because it doesn't give it to you, but you can figure it out based off of the information given. All right, last one. We have the rectangular floor of a classroom is 36 feet in length and 32 feet in width. A scale drawing of the floor has a length of 9 inches. What is the area in square inches of the floor in the scale drawing? So you think to yourself, I got 36 by 32, and I'm looking for area. So you're doing all this, you get 1152. And then you're like, well, if the length is 9 inches, how does that kind of help me out? And it doesn't. Okay. So what we want to do, because they give you the right language, is we want to do a proportion. And if you've been with us long enough, you know that, if I can write this, I'm going to try really hard. We have something called matchy-matchy. So matchy-matchy sets up your proportions, right? This is a proportion, 2 fractions set equal to each other. So we need to figure out what our matchy-matchy is. And matchy-matchy deals with the terms that they use. So whether it's inches over feet, or ounces to pounds, or miles to kilometers, or whatever it is. So what I want to do here is I've got length and I've got width. So I can use length and width. So that's what I'm going to do. I'm going to do length over width. That seems okay. So take all of my lengths. My length is going to be, and it's going to be, remember, you're doing the big object over the small object. I'll do a couple of them for you so you can see it. So I've got a length of 36 feet. And then I also have a length of 9 inches. So 36, oops, no. Sorry. Let's stay with it. 36 and then 32 for my width. So then the smaller, the scale version, has a length of 9 inches, but then I don't know what the width is because they didn't give it to me. So that's the first step in solving this problem. So how do we go ahead and solve proportions? We want to cross multiply and divide. So I'm going to bring this over here so you can see it. I'll show you a couple of ways. 36, 32, 9 over x. What I would want you to do is pick up your calculator. Okay. And remember, we go cross multiply. So what I want to do is I always want to cross the two numbers. So it's going to be 9 and 32. So you do 9 times 32 in your calculator and you get, I'm just going to write down 288. Oh, you get 288, but 288 is still in your calculator. Now, the only number that's left is 36. So in your calculator, hit divide 36 and you get, it would be divide 36 and you get 8. So I've got 8 as my width. Now, you're like, I got the answer. And then you go back and you say, oh, wait a second. I don't know, or I don't care what the width is. I do care, but that's not what it's looking for because I got 54, 72, 144. It asks, what is the area of the new scale drawing? Not what, find the width, but you have to find the width in order to get to the area. Okay, so 8 is our number. Now, let me go through that long version because ultimately, I want you to get to the point where you do all these in your calculator so that you can save time. But it's 36, 32, 9 over x. I end up with 36x equals 288. Divide by 36. X equals 8. So that's my new dimension there. If x is equal 8, and that is my width, so that equals width, and my length is 9, well, then all we have to do is 8 times 9, and we get, let's do that better, 8 times 9, which equals 72. 72 is the area on the scale drawing in square inches. Okay, so you see how it's like a two-parter. Don't get lost. That's what we do with these multi-step problems is we get lost. We find an answer, like we solve a variable in this case, and we're like, woohoo, I got 8. All right, what do I do with 8? And then you got to say to yourself, okay, go back. What is the question? The last sentence is always the question of the test. So it says find the area of the scale. 7 inches by 9 inches gives you 72 inches. Let me just show you a couple more ways to do that matchy. All right. So for that, you could have done, and I'll show you why it works. You can do it. You can always do it 4 different ways. I've got feet and I've got, I got length and I have width. So I could have done, you can do length of the big over length of the small is equal to width of the big and of the small. In this case, my matchy would be big over small object or scale object. Okay. Do it whichever way you feel more comfortable with. I always like using the language that's in the problem, but you'll see how this is still 9 times 32 and then 36x, 9 times 32, 36x. It's just, put things in a different spot, but they're still the exact same thing, right? You don't always have to do one way when you're solving a proportion. You can manipulate the numbers around many different ways, 4 ways to be exact. Okay. All right. That is it. Last slide is always the answers. So got to make sure you've got the answers so you can check yourself and make sure you're on the right track. All right. So that is it for this week. If you have any questions or you want to send me any sample questions that you want me to put on the live sessions, please email me at info@kathleenjasper.com. And I will get it. I will put it on the following week's session for you. And that's it. Okay, let me see. Let's see. Usually some questions pop up. All right. Could I use scale factor? Yes, you could use scale factor. They're asking for this one right here. In this case, and I'll leave this up, but if we have 36, you take your length and your length. So you either have 36 over 9, which is 4, or 9 over 36, which is 1/4. So what this means is if I do big over small, it means that the big one is 4 times the value of the small one. And so if my width is 32, right? So if my width is 32, my big one, that means I divide by 4 and I get an answer of 8. If it's 9 over 36, that means the small one is 1/4 or 4 times as small. That's when we do what number times 4 is equal to 32. So again, yes, absolutely. You can do scale factor. It's all a matter of how you understand scale factor. And if you can do it that way, by all means, please do. I never force you to do any of these problems one particular way. I try and show as many ways as I can think of at this time that I'm taping this. But other than that, yeah, as long as you understand it, because sometimes I'll say it one way and then someone will say, oh, can I do it like this? Like for example, this scale factor, and looking at this, it just might've just confused them completely. So just erase that from your memory. Don't even think about it and go back to using your proportion, because ultimately it's all the same thing, right? It's just a different looking or a different perspective on the operation. Okay. Again, the email address, info@kathleenjasper.com. If you're on YouTube, you can still comment on the YouTube, and I still will get it. And then I'll answer it back to you. Send me the email if you still have a question, if you're watching this on the recording, and I will get back to you. But kathleenjasper.com. We're on Twitter, Facebook, Instagram, all the major socials. You can get a hold of us in any way. We don't just do math. I do math sessions every Tuesday because I want to help you all out. I want you to get past these math tests. I know they're just hindering you. And so I'm trying to help out as best I can. But we also offer many guides, online courses to many other different certification exams. And then check out our YouTube channel. Our YouTube channel is jam-packed. We have tons of videos. It's all free content. It's all good content, and it's worth your while. So I will not be here next week, taking the daughter on a little summer vacation. We will be back in 2 weeks from today. I hope you all have a great week, 2 weeks. I hope everything's going well for you. Hope you're enjoying summer. The weather's great. And that's it for me for tonight. Everybody have a fantastic couple of weeks. If you need anything, please let me know. But other than that, I will see you next